Today's lesson is on law of sines. This is the first time we're going to do trigonometry without right triangles. So far, everything we've done has been right triangles. So sine and cosine are going to be used, but in a slightly different way. So in law of sines, before we get into it, we have to talk about a couple of things. First, we have a triangle that's not a right triangle. It'll still work for right triangles, but for most of the problems we're doing, they're non-right triangles. So keep in mind that the angles are going to be capital letters, and then this concept of sides opposite angles is going to be used again. So if we look at angle A, side A will be opposite that, and if you look, capital A is opposite small a. Small a represents the sides, right? The small are lowercase, and the capitals are angles. Right, so then if we have angle B, side B goes here, and angle C, side C goes there, right? So we need to make sure we label our triangles appropriately and understand that the angle has a matching side and a side has a matching angle, vice versa. All right, so here's what the law of sine says. It says if you take sine of the angle and divide it by its side that's opposite that angle, it's equal in proportion to the other angles in their opposite sides. So you have this. Now typically you're only given two proportions, but in this particular scenario, they're all the same. And so when we get into examples, it'll make more sense. All right, now when do we use law of sines? Well, when we talked about triangles in the past, Pythagorean theorem was used for right triangles when we were given two sides and we want to find the third. In the right triangle trigonometry, we're either given two sides to find an angle or an angle and a side to find another side. So in this case, we're going to be given two angles and only one side, and that will allow us to find another side length. Or we're given two sides and one of the angles opposite them. Okay? So, and you'll start to see these two types of problems throughout the examples we do. So in this example here, they give us triangle KLM. So the first thing is to draw a picture and label it KLM. And it doesn't matter how you label KL and M, and it's probably not going to be to scale, and that's okay too. What you want is just a visual representation because we want to match the angle to its side that's opposite. All right, so here angle K is 120, so where I marked angle K, I'm going to write that. Angle M is 50, and then side ML is 35. And so if we look here, ML is this side length right there. Okay, and then they want you to find KL. So KL is going to be this. So the first thing we're going to do in these problems, if it's not already given to you, what we're going to do is we're going to connect angles to their opposite sides. We want to connect these things. And the reason that is I feel like this is a really good visual representation to make sure that you write your fractions appropriately. So we had talked about the sine of one angle divided by the opposite side is equal to the sine of the other angle divided by its opposite side. And so here you see that the sine of 50 divided by x is equal to the sine of 120 over 35. Now, up until this point, we've seen variables on top and variables on bottom. And so we're going to cross multiply and divide. And so what ends up happening when we cross multiply is we do this. Okay, and then we're going to divide by this. Okay, so what happens is this: if we look at the top part of the fraction, right, we notice that these two things were cross multiplied, 35 times sine of 50, and then we're dividing by that. And so this is a visual that I'm going to have you guys use as a shortcut. So wherever the variable is, we're going to start on the other side of the equal sign from it. Then at that point, we're going to cross multiply and then divide across. Okay? And so what we do is then with this fraction, we use the ND button, and then you'll get 31 as your answer when you round it. Okay? So again, we're going to cross multiply these two because we start where the variable is, we go across from it, cross multiply, and then divide. Okay. Now, if you don't have the ND button on your calculator, put this in the calculator, hit enter, and then divide by that, and then that should work for you. Okay. All right, so down here we have another one. Now this time the image is drawn. So the first step, since the image is drawn, the next step then is to go opposite. Now they want the length of EG, which is this. Okay, and what we do is we find out that there's nothing there. So we need to say, okay, what do we know about angles of a triangle? Well, all three of them have to add up to 180, and we're given 2. And so when we add these up, we get 100, subtract it from 80. So now we have our fractions. So we have sine of 43 over 4.56, sine of 80 over x. Okay, and it doesn't matter if we did sine of 80 over x first and sine of 43 over 4.56 second, that would work. But what has to be true is that the 80 and the x go together, the 43 and the 4.56 go together. Okay, so where's the variable at now? The variable is here, so we're gonna start over here, cross multiply, and then divide. Okay, so we cross multiply 4.56 times sine of 80, and then divide by that, and we should get 6.6 for your answer. Okay. All right, so in those two cases, we are finding side lengths. Now, what we're gonna see in a second is finding angles, and when we find angles, we're gonna use the -1 button, or we're going to use 180 minus the 2 given triangles. So up here, we have 2 angles. To find the third, we're gonna do 180 minus that. And the reason we need that angle is because it's across from angle B, okay? So then, in this case here, what I used is sine of 13 over 9, and then I did B first. I'll do A second, but we could have done A first as well. All right, so in this case, where the variable is down here, so we're gonna start across from it, cross multiply, and then divide, and then you should get about 23 for a side length. Okay, so up here we know that this is 145 because we figured it out previously. This is going to be about 23. So for sine of A then, it's going to be sine of 13 degrees over 9, sine of A, which is 22 over A. So again, where's the variable? It's down in the bottom, so we go to the opposite side, and then we cross multiply and then divide. And we should get an answer really close to 15 for that. Okay. All right, so if we look down here, we have another one. This time we're finding angles, so we're gonna use the -1 button. PQR, we're gonna label our triangle any way you want. Plug in the value here, so 97.5. R is 80, so R, small r represents the side across from angle R. Small p represents the side across from angle P. We wanna find angle P right here, okay? So this is what we're trying to find. So we would draw our triangle and then draw the lines opposite. Kind of creates that X. So we look here, and now where's the variable at? Well, the variable is up here this time. So we're gonna cross multiply and divide that way. So if we look at our formula, it's 75 times this divided by 80. Now what's gonna happen is, because we want to find the angle, we need to do sine -1. So a couple things. If you were to type this in the calculator, you're gonna get this decimal. Then you could take sine -1 of that 4 decimal place number. So if we're gonna do this, it's gonna be the 4 decimal places. Where are we at here? Sorry. We need to go to 4 decimal places. The other way to do it would be to, from here, from this step, in your calculator, hit sine -1, then hit the ND button. And when we do ND, this part will go on top, this part will go on the bottom, and then when you close it, you should get 68 as your answer. Okay. All right, so let's try another example here. Okay. They want us to find everything, all the angles, all the side lengths. So in these problems, you're gonna have one pair. You have to have one pair for this to work. You need an angle and something opposite for all these problems, for any of these to work. So in this case here, we have side length 9.8, so we're gonna find angle X first. So since the variable is up here, we're gonna go across, cross multiply, and then divide, and then put that into sine -1. So you could do sine -1 of this whole thing in your calculator, and you should get about 15.5 for your answer. And depending on what the directions say, we may want to round up to the nearest degree, or we may round to the nearest tenth of a degree. All right, now that we have that, we have two angle measures, so now we can find the third. So if we add these up, subtract it from 180, we would get 124.8. The reason I kept it as 15.5 is because in the original problem, 39.7 was kept. If this were just a whole number, I would have rounded this to a whole number as well. Okay. All right, so then over here, we set up our equation, sine of the angle over the opposite side, and then I'm gonna pick any of these side lengths, okay? And I decided to use the one we just calculated. So the variable is on the bottom, so we start opposite the bottom, cross multiply, and then divide, okay? Now in this case, do we need to use -1, the sine -1? We don't, because this is a side length, and the -1 button is only used for finding missing angles, okay? And so we would get a value of approximately 30.1, okay? So again, here's your summary. Set up the problem, draw the triangle, label it appropriately, cross multiply across, so again, start from where the variable is, go opposite, cross multiply, divide, and then calculate, and then use sine -1 if the angle is missing. So that's the summary of steps that I would recommend you guys write down and then use over and over again.